According to the standard model of cosmology, building a supermassive black hole is a process that demands billions of years. A massive star runs out of fuel, collapses into a stellar mass black hole, and then slowly accumulates surrounding gas, growing fraction by fraction over cosmic epochs. But observations from the James Webb Space Telescope show monstrous black holes already dominating the universe, a mere 600 million years after the Big Bang. It is a chronological impossibility. Finding objects this massive so early in the universe is like planting an acorn and watching it instantly expand into a fully mature oak tree. This discrepancy has forced astronomers to re-examine the mathematics of the Big Bang timeline and the constraints of the standard cosmological model itself. While surveying deep space imagery for the earliest forming galaxies, MIT researchers noticed a recurring anomaly in the data. The images were littered with tiny, glowing anomalies that the team began referring to as little red dots. One specific dot, designated MOMBH*1, stood out from the rest as an extreme outlier. It spans roughly the size of our solar system, yet it emits radiation equivalent to 100 billion suns. That energy output completely eclipses the physical limits of any known star, but its highly condensed footprint doesn't match the profile of an early galaxy. The data left researchers with a single conclusion: MOMBH*1 belonged to an entirely undiscovered class of astrophysical objects. To understand what they were looking at, the team turned to spectroscopy, a technique that separates incoming light into distinct wavelengths to reveal the chemical composition of deep space objects. Because the object appeared intensely red, the initial assumption was that a thick veil of cosmic dust was scattering the blue light, similar to how smoke affects the color of the sun. This graph plots the object's light spectrum, and it reveals a massive anomaly, a sheer vertical drop-off below a specific wavelength. Astronomers call this a Balmer break. It indicates that the light is passing through an incredibly dense, turbulently swirling cloud of pure hydrogen gas, completely free of any dust. The spectrum showed almost no traces of metals or heavier elements. Combined with an energy output 100 billion times brighter than a normal star, standard nuclear fusion was mathematically ruled out as the power source. The only engine capable of producing that much energy within a dense hydrogen cocoon is a black hole, perfectly masquerading as a massive red star. The researchers named this newly discovered entity a black hole star. It consists of a massive star-like envelope of gas with an actively feeding black hole at its core. To understand how this structure forms, we have to look at the Eddington limit, a physical law that dictates the maximum speed at which a black hole can consume matter. When a black hole feeds, the immense heat generates outward radiation pressure. If it eats too quickly, that outward force overpowers gravity and blows the incoming matter away, effectively starving the black hole. But MOMBH*1 is structured differently. The singularity is deeply entombed within a dense solar system-sized envelope of hydrogen, and that thick wall of gas ensures the outward radiation remains trapped inside. This trapped environment creates a state known as Super-Eddington accretion. Because the gas cannot escape, it is forced inward, allowing the black hole to consume material at more than 4,000% of the theoretical limit. As the black hole gorges itself, the surrounding outer layers of the hydrogen cocoon absorb the extreme energy, swelling and glowing to project the illusion of a giant red star. By bypassing the universe's speed limit inside a high-pressure, hidden environment, the black hole rapidly gains mass from the inside out. This mechanism explains how supermassive objects could exist so soon after the Big Bang. The discovery of the black hole star accounts for the presence of mature mass that standard cosmological models previously could not explain. Rather than being an isolated anomaly, MOMBH*1 represents a heavy seed. These enormous objects were likely a common foundational phase in the architecture of the early universe. Heavy seeds had volatile lifespans. They gorged rapidly on pristine hydrogen gas before explosively ejecting their false stellar envelopes, revealing the massive singularities hidden underneath. Once exposed, the immense energy output from these supermassive black holes regulated the environments around them, dictating exactly when normal stars could form and when they would cease to exist. This history leads directly to our own cosmic neighborhood and to Sagittarius A star, the supermassive black hole anchoring the center of the Milky Way. The density of these little red dots across the deep space data suggests that the black hole at the center of our galaxy likely began its life as a heavy seed, passing through this exact same swaddled, monstrous phase. JWST has identified the high-pressure engines that dictated the formation of the modern universe.